Question 27. A sample of magnesium metal containing some magnesium oxide as impurity was dissolved in 125 milliliter of 0.1 NH2SO4. The volume of hydrogen evolved at 27.3 degrees centigrade and 1 atmosphere was 120.1 milliliter. The resulting solution was found to be 0.02 N with respect to H2SO4. Calculate first the weight of the sample dissolved and second the percentage by weight of magnesium in the sample. Neglect any change in the volume of the solution. The volume of H2SO4 is 125 milliliter and normality of H2SO4 solution is 0.1 N. The equation for the reaction is magnesium plus H2SO4 forming magnesium sulfate plus hydrogen gas is evolved and magnesium oxide also reacts with H2SO4 forming magnesium sulfate plus H2O. Now equivalents of H2SO4 present is equal to normality of H2SO4, that is 0.1 N, into volume of H2SO4 in liters, that is 125 divided by 1000, and this is equal to 0.0125 equivalents. Equivalents of H2SO4 left is equal to normality of H2SO4, that is 0.02 N, into volume of H2SO4 solution, that is 125 divided by 1000 liters, and this is equal to 0.0025 equivalents. Therefore, equivalents of H2SO4 reacted is equal to equivalents of H2SO4 present, that is 0.0125 equivalents, minus equivalents of H2SO4 left, that is 0.0025, and this is equal to 0.01 equivalents. Now applying the equation, P1V1 by T1 is equal to P2V2 by T2, where P1 is the given pressure, V1 is the given volume, and T1 is the given temperature, and P2, V2 and T2 are pressure, volume and temperature at standard conditions. Therefore, P1 is given as 1 atmosphere, V1 is given as 120.1 milliliter, T1 is given as 300.3 Kelvin, P2 is 1 atmosphere, T2 is 273 Kelvin. Solving this equation, we get the volume of hydrogen, that is V2 is equal to 109.2 milliliters. This is the volume of hydrogen evolved when magnesium reacts with sulfuric acid. Now equivalents of magnesium is equal to equivalents of hydrogen. Equivalents of magnesium will be equal to weight of magnesium divided by equivalent weight of magnesium, which is 24.3 divided by 2, where 24.3 is the atomic weight of magnesium and 2 is the valency factor, and this is equal to equivalents of hydrogen. Equivalents of hydrogen will be equal to volume of hydrogen evolved, that is 109.2 milliliters, divided by equivalent volume of hydrogen, that is 11,200 milliliters. Solving this equation, we get weight of magnesium equals to 0.1185 gram, and from the same equation we get equivalents of magnesium equals to 0.00975 equivalents. Now equivalents of magnesium plus equivalents of magnesium oxide is equal to equivalents of sulfuric acid reacted, and this is equal to 0.01 equivalents. Therefore, from this equation, we get equivalents of magnesium oxide equals to 0.01 minus equivalents of magnesium, which is equal to 0.00975, and this is equal to 0.00025 equivalents. Therefore, weight of magnesium oxide is equal to equivalents of magnesium oxide, that is 0.00025 into equivalent weight of magnesium oxide, that is 20, and this is equal to 0.005 grams. Therefore, total weight of magnesium plus magnesium oxide is equal to 0.1185 grams plus 0.005 grams, and this is equal to 0.1235 grams. Therefore, percentage of magnesium is equal to weight of magnesium, that is 0.1185 gram, divided by total weight of magnesium and magnesium oxide, that is 0.1235 gram into 100, and this is equal to 95.95%.